All right, everyone, welcome back. The purpose of this video is to take you through a basic demonstration of what it is we're hoping we can expect to discover and explore with the activity assignment number 5, which is the mobile GPS lab, or another way of saying that, our GPS field elevation survey using the collector for ArcGIS. So this will be the new app that is not the classic app, but the new one there. So to begin, what I'm going to do is reference the iOS processes and the Android processes that I did in the overview video for this week. And so for you, if you are an iOS user, you will want to click here. And if you're an Android user, you will want to select the second one. And in the overview video, I did explain some of the differences between these two. So if you didn't get a chance to, go back and check that out. But for now, in the processes that I was using with my device, I have an iOS, so I'm going to select this process. And largely, in recap, they flank each other fairly well. Just that there's a few steps that the Android process will entail. So let's go ahead and open this up. So if you have this document in front of you, please open it and refer to it, print it out, or whatever you have to do, but I'll be stepping through this document. I'll have another monitor that I'll be looking at just to kind of nurse our way through here, take you through the lab. So you want to reference this document as we go. So first and foremost, what we'll want to do is, whether again, if you're an iOS or Android user, go to the store, wherever you need to go to get those. In this case, it's the Apple Store. Download the collector app and install it. And once it's installed and you open that up, there'll be a screen that will look similar to this right here. And so upon signing in, when you click sign in, you will want to sign in with the Arcgis Online option. So that will be the top option for us, at least on the iOS version right here. So when we sign in, now this goes for both people, whether you're an Android user or an iOS user. One of the things that we'll want to make sure that we both do in both situations will be to log in. You'll see on the screen right here, I'm highlighting this. Log in with the smumn.user login. So smumn.user. So this will be both for your username, just as shown here, and your password. So make sure that that login or that those credentials are for both your login and your password. Once you are successfully loaded in to the system or logged into the collector app, you'll see something that looks like this on your screen. And we are going to select the top one here, which is the elevation collection map. That's the one that has been shared out with our smumn.user account here. And so we will all be dropping our data into this particular map. Some of that is so that I can see what you're doing if you need help, or if you want to see or use my data for any particular reason, you can see my data as well as other people's data too, just in case. But it's mainly a way that I can try to help you if something isn't right, or again, if worst case scenario, if you want to use my data, you can around Winona here. But also, I reference here that you may want to choose to select your silhouette icon, which is this little one right up here in the upper left for iOS. Android, it might be on the right, I think. Not quite sure on that, but if you select your silhouette of your icon, you can go in there and start to change or at least explore the GPS settings. And so, like I said, in the prior integrity session, the new collector is really pretty user-friendly, and you can figure this out in probably 2 minutes just tinkering on your own. But to show you that the settings for your GPS will be under the silhouette icon, it's just something to look at. For the default for this lab, originally when I was going through this, they were set at automatic, so that's how I'll try to proceed. But if you do want to tinker and change them to decimal degrees or UTM or something like that, you could try that, I guess, and see what happens. But otherwise, the default settings for me in this lab were set at automatic with respect to units and collection coordinates, things like that. So the collection coordinates for the lab in this case would be Web Mercator. So that'll be native, I think, a meter unit for that. So just if you expect to see latitude, longitude, you will not see that unless, I don't know if you can set it here or not, but if you leave it for automatic and just the Web Mercator projection a collector will use, those default units will likely be meters, I believe there. So just to give you a heads up on that. So let's move down to step 4. So as you're looking through this here, one of the things that you'll see is that right off the bat, the minute that you try to go into your elevation collector mapping application, you'll see that location access is denied. In other words, your GPS is not activated. So what you'll need to do is, if you're an iOS, go under your settings, or even before this or beforehand, then you will not be prompted with this little access denied warning here. But go in under your settings and under privacy and then activate your location services. And once you are able to do that, make sure that you're outside. Well, inside, you can practice this first before you go outside just to see how the whole app works. But once you have that process down, you could go outside, and then you'll see here in the next step on number 6, you'll see that right now in this illustration, I was actually in the building. I was inside here, so my GPS accuracy was not sufficient enough to even take a point because I was indoors. So I wasn't able to collect any point. Well, I still could collect points, but nothing that would be GPS relevant really. So number 6 refers to collecting a data point, and iOS and Android both have a little button here, a little plus button that you'll push to collect a point. And what we're showing here in number 6 is once you have your position fix under 30 feet accuracy, usually for me when I am outside with my device with collector on, I've had accuracy of 8 feet to probably 12 to 15, maybe a little less in some cases. So you can definitely get considerably under 30 feet for your accuracy. So once you have that under 30, you'll be able to select an elevation point. So right here in number 7, we'll click on Add Point. And what this will do then, right here in this case, this was my presumed feature or my presumed location, even though I was sitting in the office here. So you can, later on here, I'll show you how to, actually number 9 here, where you can touch the screen and drag your actual location to where you are. For example, if your accuracy reference of 30 feet is unattainable, you can select a map and drag to a location, and that's kind of what I'm doing here to where you really are. But if you do have a good positional fix under 30, these two circles will be aligned like you see here in number 8, and in which case add point. And okay, and here you see if we do not meet the record accuracy, the add point will appear in red, but otherwise they'll be together, I think blue, kind of like this here. So number 9, what it is that we'll be doing if we needed to move that around, like we said with the map, select the screen, drag that off, and then click add point once the feature is correctly positioned. Now number 10, what we can do is we're going to explore our attributes that are set up for you. So the attributes really are the fields that will be common with all the points that you're collecting. So to see those, simply swipe up on your screen right here, just drag this up, and you'll see the collector options here. So really these are the options for the data collection process. So you'll see your elevation points, the ability to take a photo, attach something to that. But for us, the first step would be, when you see the other 4 here, so if we look at all 4, the collector will be the name of the individual, which is shown over here in step 12. Collector notes might be if there's anything in particular that you are interested in recording for you later on in the lab or the mapping, kind of like what we did with the total station. This might be a storm drain, or it might be the edge of a fence, or it may be the edge of a wood line, or the edge of a road, or something like that, or bottom of a ditch. These might be little helpful notes for you to add under the collection notes tab here. And then the elevation we'll get to in a bit. And then if there are any error notes, you're alongside of a building, that may pose a potential source of error for you, horizontal and vertical error. But at least for now, some of the big ones that we'll want to make sure that you do for certain will be to click on the collector right here, that's shown in red, and then place a check mark by your name. So in other words, for me, it would be clicking on John E, and I would be designated then as the collector of that particular point. Let's move down to step 13. Once you select your name, that should appear as the collector is shown. And then in 14, what we will do here, this is really the main difference between these two processes. So Android folks, I'll have you refer to the Android document, in which case there are a few other steps in there related to adding or installing or downloading another GPS app. And so what you would do in that case is pull that app up at each point and then click in this elevation box here, this option, and then physically enter in whatever that elevation will give you. So for iOS users, we are not going to worry about that right now, because when we collect and record our point, that Z value is automatically being stored with our feature and in decimal value. So it's giving us a particular decimal range in elevation, whereas maybe the Android folks, your elevation will not be super specific down into a decimal range. So iOS folks, leave elevation blank, as it says right here, because the software will calculate this for us later, automated fashion here. So then in back, once we're done with our data entry, all we will need to do, if you're typing in elevation or anything like that for Android folks, you'll want to do that. But otherwise, iOS folks, we will be ready to go. And then we'll simply select submit. And Android folks, your process might be a little bit different, like with a check mark or something like that. So just submitting the information there. And in number 17, if at any point you find that you accidentally created a point that you did not want, or there was something problematic with it, or you entered the wrong elevation, here are some ways to help you edit that particular feature or to remove that feature. At least in iOS, the main process will be to, number one, select your point. In other words, tap on it on your screen, and then the feature will show up on your screen right here. And you'll see these little three ellipses or dot, dot, dot next to your point. And that may be down at the bottom, or it may be up here depending on where your window is. But at that point, you can select that option to either undo a particular entry or to modify or edit that particular feature. So if you entered in the wrong data collector, you could go back and edit that feature and then select your appropriate name, for example, or add another note that you wanted to maybe add that you forgot about. And then at this point, save that, and then just simply go from point to point, again, looking for areas of elevation change where you'll be recording a feature. So I would say at a minimum, what you'll want to do for each particular point in your survey is to go out and use your collection button right here for every point. And most points you will probably just need to record the information about you. So just like this. So you'll push that data recording point, enter in the collector, and then simply say submit right here, just like shown on the screen, and upload those, because all we're doing is really uploading elevation data. But those other options there with respect to error or different notes are for particular features that you may want to take a photo of or something like that. Which, to that end, I will or should maybe mention that you can use this take photo option if you do have a point that you're interested in and recording, maybe to help show an area or show a feature or something like that. I collected a few photos and some of the sample data that I used that you can see in the data collector application, in the data collector elevation application. So you can see my data just on campus here in Winona and see some of those photos later on. And that's, I guess, kind of where number 15, 16, 17, we're going with that. So once you've completed all of your data entry, data collection out in the field, what you'll want to do is you can close down your app and everything should be uploaded. Again, this is with the belief that you do have cellular connectivity to upload your points one by one. I don't think it should take a terrible amount of cellular data to do that, just uploading points in synchronous fashion here. But once you're done collecting those, what you want to do is come back in and log into arcgis.com. So if I do that for you here, we'll show you what that looks like. We'll pull that up here. Let me just pause that and we'll get this up. Okay, so once you are able to successfully navigate to the arcgis.com web page, simply sign in right here. But before you go any further, here we will use smumn.user, not your personal or your student ArcGIS login. We are using the smumn.user for both your login and your password. So we'll select login. And everyone should see a screen that looks like this. You should see your smumn.user account up here. Again, this is so we all can kind of work with and see data together. And whoops, let's come back down here. So that's where we are at here, finishing up with number 18. And if we move down to number 19, what we'll do next is select gallery, and then we will search for the elevation collection application that we'll be working in. So let's go ahead and do that next. So I'm going to go up here to gallery, and we either can we can just search for this, or you could go down to date modified, and we know that within the last couple of days here, we would have created that particular mapping application. So let's type in their elevation collection. And here you will see that this showed up right here. Let's go ahead and go into that. And underneath some of these other options here, we'll show you here in a minute where we will open this up and bring it into ArcMap. So here's our application in our gallery. And what we're interested in doing in this case is we are going to go right up here to open an ArcGIS desktop and then open an ArcMap. And that's what we're referring to right here in step 20. Step number 20. Once the elevation collection map is returned, we will open in ArcGIS Desktop and then open an ArcMap. So let's go ahead and do that next. As this is happening, you'll see that there is an item down here. It says item, well, 2 for me because I think I already have one in there. But it'll say PK info on it. And this is what you will also see, except yours will probably be item.pkinfo, something to that effect. And so what we'll want to do is open that right from here. So let's go ahead and open that up. Actually, I do have it open here already. Okay, I just checked a few things up because I already had a session open with my ArcMap. So one of the things that we'll want to do is once we go through this process here and go into Open ArcGIS Desktop and ArcMap, what will happen is there will be a document download right here called item 2. So if you were to, well, for me, item 2, but yours will say item PK info on that. So go ahead and double click on that and open it. And what you will see will be something that looks like this. You may get a warning, and it's okay to say yes through that. And if you do happen to get a warning about pending, something pending there, And so inside of this, what we're looking at are our points. And for what we have here in Winona, this is my data points that I collected as sample data sets. So folks, if you're having problems, you can use this data for your lab if you do need to. If after trying something doesn't work or there's a problem, let me know. But in here, what we're doing is we're taking a look at everyone's point. You'll be able to see everyone's points in here. And so when this opens, what we're looking at is that service that we're in effect kind of streaming in here to our session. And so let's go ahead and take a look at our guide to keep us moving along here. And so we'll be moving into 22, which really moves us out of collector now. And now we're moving in to really the start of more or less our lab work and really working inside of ArcMap at this point to explore and scrutinize our data to see what's really going on with it. So number 22 we are on here now, more in the ArcMap side now of things. So once we are in our desktop software, if you do have to do it in Pro too, I guess you could do that as well. And so what we'll do is select the points that you created. So right now it's pretty easy for me because it just says John in there. But if we have 10, 12 of us collecting data in there, you'll see all sorts of points all over the place, but you will know where your own data is. So what you'll want to do is to zoom to your area where you were, just like I did here. And then you can simply either use your select tool, your selection tool, select features, and draw a little box around them like that. That's one way. Or number two, you could go into the attribute table, clear our selection here, and you could run a query for all of just your name. So you could run just a regular attribute query. And, or if you did find your name in here, you can just simply highlight those two. So a lot of ways to select your features. Probably the easiest is just to zoom in and then select those point features that you collected. So if I zoom in on my area a bit here, this is just off the southeast side of campus here. This is a really, really sort of a long gradual slope, and there's a stream that runs down this way here, and a small little access road with a culvert running underneath it. So not super steep, but yet there was enough of a gradient change. We'll for sure be able to get some really neat GPS measurements from that. So as you can see, what I ended up doing was started up top and then made a couple of transects back and forth and collected along this ditch here. Could I have been out there longer? Absolutely. Should I have been out there longer? Probably. I probably could have taken 10 to 20 more points out here pretty easily. So the objective for you is to say, what is going to be good for my to create a surface off of. Obviously, we're not going to be able to take a measurement every foot, but look for those points where elevation change are occurring and capture those areas really, really well. It started to rain a little bit as well out here, so I was kind of making a quick dash here for the points, but you can see them scattered around the area. So this is higher, this is lower down in this area here. So this would be the lowest point of the area here where I surveyed with the collector app with GPS. So from this stage, or from this point here, let me go back and reselect all of my features. So right now, we are selecting our features right here in number 23. And what we'll do is export those out, because we really can't do a whole lot because we're still working inside of our feature service here. So what I'm going to do next is simply right-click on my elevation points, and I'm going to go down here to data and then export data. So I'll go ahead and select this option, and that's fine. I can use my same data source. Now it's up to you. Please keep your data organized. If you have a nice little folder with no spaces in the path directory, that's something we want to do. For example, if I were to say week space 5 space materials, we do not want to do that. maybe use an underscore or something like that, but there should be no spaces in your path directory, your path name. So save this to an output location and give the file an appropriate name so that you know what this is. So for me, I called mine Jan's data or Jan's field data because that's what the building is here, the residence hall. So go ahead and export those out. And once you have those exported out, what you will see will be some points that will come in for you. And I'm just going to go ahead and add mine in here. I think my originals were, I actually have it up in another session here. Let me pause and I'll get that up. All right, so once you export your shapefile or export your data and you save your shapefile, that shapefile will drop into your table of contents over here on the left. So one of the recommendations that I reference here in number 24 is you may wish to start a new data frame and just move your shapefile to that. I'm a big proponent of moving data and keeping it away from any services or features we're streaming or anything like that, or when we're dealing with projections or anything. I always like to keep data clean. And the best way we can do that is by inserting a new data frame, because it's not bottled up with other problems from other data sources that we maybe were working in a prior data frame. So what I'm going to do here is I'm going to move my data set that's in a shapefile now into my new data frame, and I can move my base map imagery in here too. And this should give me now a clean data set. There's no problems. Again, this is the Web Mercator based projection in meters here. So that's what we're working in. We can project this data. If you're not a fan of this, we could project this data out into a typical projection used here would be a universal transverse Mercator. You probably worked with that in some of your intro courses. That's a cylindrical transverse Mercator, which does a good job at preserving zones, or really north-south preservation. That's why we see UTM in these zones, like zone 15, for example, is what we are in locally here in Minneapolis, St. Paul, Winona area. We're in zone 15 because it preserves those zones really, really well. So that's for another course. We're not really getting into that too much, but if you wanted to take this data out, if it bothered you, you could project that out. You could even unproject it, if you will, into a geographic coordinate system like latitude, longitude. But that may present some other mapping problems later on, so it may be okay to leave this in a projected coordinate system for now. So here we have our data, shapefile format. One of the big rules I always love to do is let's explore this data. Let's see what we have in here. Let's see, we have our collector information. We have some of my collection notes. This was a tree, which was the start of my high point way up top. So if I show you where that is, you can see where I started this survey right up in here. And you can see where the picnic table was, where I took another reading by. And there's a culvert that I collected. That goes down here, culvert inlet. So this was at a very, very low point of the survey. So if I move that down, you'll be able to see where that culvert was. And then I took another point just up from that, which was part of the road, access roads. You can see that there's a great deal of drop off around there. Now, whether or not the GPS recorded that, that's what we are trying to determine, the accuracy of this GPS. So explore your data. Always know what you're up against. The other thing that what I'm going to do is check out my properties, look at my general or my source information, and that's telling me that my data is in that Web Mercator, just from the ArcGIS or from the map service that we were looking at initially. But I have my shapefile here, and it's a point data. Do my coordinates have Z values? Yes. So Android users, you may not have this. That's why you had to record specially your elevation data. So Android users, if you are here looking and exploring, you will see that you have elevations already populated in here. Now for iOS users, at this stage, you will not have any elevation data in here. So make sure that you're checking this out right here. these will not be here for you, okay? The only reason that they're there for me now is because I calculated them, and I'm going to show you how to do that next. So let's come back over here to our document. So we went through number 24, and number 25 is where we'll be leaving off for iOS folks and Android people. You will already have values entered in here because you use your other app to do that. So, but this is really the fun part for iOS users, that you'll be getting down to, I think, some pretty specific GPS Z values that your GPS was able to calculate for you. So what we'll do is open up our attributes, and then we'll right click on the elevation field and select calculate geometry. And as noted, Android users, you might already have those populated. So I provided a screenshot of what that would look like for you. You know, right here in my demo, you could see that this elevation field, there's nothing in there. There should be nothing in there for you for iOS folks. So we'll right click and then calculate geometry. And then a very important step that you'll want to make sure that you catch is right here. So when calculating your geometry, please make sure that you select your, what does that say there? Can't read that, the property or the drop down there. What you're interested in calculating for that geometry is for a Z value, not an X, not a Y, but you want to make sure that your Z is specified because that's your elevation. Oh, and also under units, I selected mine as feet just because I know around here what my normal feet elevations are. So you may want to do the same, or you may want to set this as meters that I reference right here. That's okay. The ground's not going to change. It's just a matter of how you're more comfortable reading elevations in feet or meters. It's one of the same there. So again, I'm not going to change anything. But for me, the biggest thing, make sure you have Z specified right here as shown above. And then if you want to use feet, you can do that. So let's go ahead and I'll see if I can try to replicate that here for us. Unselect all these things. So under my data set, I'm going to go into my attribute table, and then under elevation, folks, here's where you want to calculate your geometry. And I'll go ahead and just continue this just to show people what you want to do. But under the property here, you will want to make sure that you select the Z coordinate of the point. So go ahead and do that. And then if you want any of your units calculated, again, I selected feet, but you can do what you wish for you. And then the coordinate system, I kept consistent here. Then select OK. And then what will happen is your elevation fields will populate automatically for you. And notice that you'll be getting some pretty specific information here that you will not likely have gotten under another app. So this is why I think with the iOS system, at least now, the elevation values are going to be a lot more refined, and I can't say it's more accurate, but it's going to, in theory, give us more accuracy or maybe more precision with our data collection. So this is the field that we will be mapping to create our surfaces, just like what we did with total station. So let's take a look at that next. All right, so step 26, we're almost done. So step 26, we'll turn on our Spatial Analyst extension, and under extensions, we'll turn that on. So let's show you how to do that, and really that's provided here in the graphic. So under the drop-down menu up here, under Customize, we'll go to Extensions, and then make sure that our Spatial Analyst extension is turned on, which mine should be. Just did that here before. And then make sure that your Spatial Analyst extension is turned on. So again, that was under Customize and then Extensions. So Customize, Extensions. Right there. Now that that is on, what we'll want to do is go into either the Spatial Analyst Toolbox, or, well, you can access this also through our catalog. And what we'll want to follow is what's provided here. So we want to create an interpolated surface using our Spatial Analyst Toolbox. So let's go in here. I just happen to be in catalog, but if you want to do it in ArcMap, that's fine too. And if I find my Spatial Analyst tools, here they are. My toolbox here, just to show folks how to get to that again. Your toolboxes can be pulled up by this icon right here. And then let's go down here, find our Spatial Analyst tools. We'll open those up. And then for me and you, we want interpolation. And I selected spline. The reason I'm selecting spline is that it's usually a nice general fit for elevation. Something like IDW or Kriging will really present to you very unnatural breaks in the data, which is not really explicitly found when we look at land and contours. You know, contours aren't going to be super jagged or super concentric around a point. So usually when mapping elevations or pollution levels or with graduated kind of easy change to it, spline is sometimes a good tool to use for that because we're not worried at this stage about anything with geostatistical interpolations or anything like that. So with your spline, go ahead and pull that up. And your input field, of course, will be your data set. So for me, it was my Jan's data set. You know, and for you, it will be whatever your point value is. So we'll go ahead and add that in just to show you what this looks like. And then our Z field, make sure that we specify elevation. So whether you're Android or iOS, if you just calculate it, you know, we just went through and calculated your elevation. This is what we'll want to make sure that we specify. And then an output raster. As with everything else, please select a location that works for you. No spaces. For me, I'm just saving mine for this example here that we're doing for the integrity demo in my temp folder. But the characters of your raster name should not be any longer than 13 and should also not have any spaces. So give this a title for your points, whatever that is for you. So provide that a title. Your output cell size will default to whatever the software is going to set for you. So if you wanted to set this to 1 or something like that, you can do that or just leave those optional. In this case, it's probably not going to hurt just to leave this as optional default. Then select OK. And what will happen is you will have a surface generated for you. And let's show you what that looks like. Well, yours will look different than mine here. But what I'm going to do is load that surface that we just created. And so for me, this is what popped in. I don't really like the way the display is showing here. So what I'm going to do is right click on my layer, go to properties. Then I'm going to go under my display tab, my display settings here. Or maybe it's under my symbology, I'm sorry. Under my symbology. Then I'm going to change my color ramp to something a little bit more elevation oriented. So something like one of these might be okay. It doesn't really matter, I guess. In other words, areas that are really high in elevation will be more of this grayish white, and then the other areas will be more green and kind of the aqua color towards the bottom. So let's go ahead and select OK for that. And here's an example of what the DEM surface created based upon my input elevation points that I collected with my Arcgis data collector app. So if we come back over to our document over here, what I just went through with you was really number 27. And for some reason, maybe it was my Arc map session, but I did have some problems with the spline interpolation to create my DEM surface getting hung up. So I had to calculate my interpolation in our catalog in the way that I showed you just here in this integrity. And I also did that for my contours just because I was in there. But you probably won't have any problems. But if you do, for some reason, there's something unique going on, you can always create the same layers, the same data in our catalog that we do in our map. It just happens we're running through our toolbox in a different platform instead of ArcMap. So that's what I'm referring to right up here in this section. Let's go down and take a look at number 28. And I went through that with you just now, that we may want to alter how that data looks in our display settings. So I took you through how to do this under the display settings with our drop down. Now number 29. Let's go ahead and create some contours under our surface toolbox. And so set your CI, your contour interval, maybe to 1 foot. You know, I suspect that most of you will be dealing with a topographic surface that's going to be not too large. I mean, we're not dealing with hundreds of feet or anything, unless you really wanted that to be the case of like a bluff or something. But so in this case, you want to set a CI that's manageable for you to work with, but that's also going to create a good readability in your data when you pull in a contour layer so that they're not all smashed really, really tightly together. You maybe want them spread out a little bit more. So try different variations. You know, try 2, try 5 feet, you know, and explore that. You can create one of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you know, contour intervals or layers that have different contour intervals. So in the example that I illustrated here for you in your handout, I used a 2-foot CI, and you can see how that looked. If I created a 1-foot CI, there were just many, many more contours. You could try this with a 5-foot CI as well. So let's open up our ArcMap session again here. I'm going to load in my 2-foot contour that I created earlier. And those are shown right here. Just going to change those to make them a little bit more readable here. Guess I could turn off my base map for the time being. And here we go. Now to calculate your contours, the same process, I think I had it in the document there, but if we wanted to calculate our contours, we would simply go in under our Spatial Analyst tools right here, and then go under our surface. I'm sorry, not our, yeah, under our surface here. Sorry, under surface tools, and then under contour. And that's where we would create our contours. So to specify and to generate our contours, we want to provide our input raster. So what this means is you have to generate this really colorful thing over here, which would be our little makeshift DEM. So you'll have to create that first before you can create your contours. So we'll specify your input raster. And then once again, set your directory wherever that is for you. Again, no spaces. Those are ideal. Here's where you could set your contour interval. For me, I used a CI, a contour interval of 2, but you may want to use 1, you may want to use 5, you may want to use 10, just the spacing of your contours, that's all. Then go ahead and run that. Again, if you have something gets hung up, you can always run this in our catalog as well. You know, the same process applies, just under our surface tools here. Same toolbox, just a different interface for which we work with it. Okay, that's how we ended up with our contours. So the next step now is we have our model created, we have our contours built. And now if you wanted to take this into 3D Analyst, you can do that. So, you know, all these assignments are scalable. What I'm showing you right now is just sort of a baseline for what you can do. So if you do have a lot of experience working with this, you know, take it a step further on your own. There's nothing holding you back on this. If you want to go into 3D Analyst or you want to do some other cool visualizations or modeling or statistical approaches with this, by all means do that. You know, enhance your product. You know, these products are always really good for you to showcase in your portfolios or what have you, but you know, take it a step further if you want to. If this is stuff you've seen before. We want to promote and encourage you to do that. So the next step here in our document, number 30, I think we just have just a couple more here to look at, is we'll go to that website here, the MinTopo website. And when you first go to this website, you will sort of be peppered with a lot of different information. In the center of the screen, there'll be some text that may say something to this effect: proceed to the MinTopo viewer. And so go ahead and click on that. And that'll be sometimes in the middle of that initial landing page. And then at this point, now we'll be using this step to determine our elevation data to compare our GPS collected data to. So let's go ahead and go to the MinTopo website. And then once we're there, we'll zoom into our study area and select a polygon of our area that we would like to receive elevation from MinTopo about. And that's really what this means here in our next step. So you can see some graphics of what that looks like as we zoom into our, well, in my case, in my area here. The closer I zoomed in, the more elevation or contours that appeared. So we'll take you through what that looks like here next. All right, so once in MinTopo, this is what you will see when you log in. And so the next step really is here for you to zoom into your study site. And so what I did is just kind of kept double clicking, or you can use your zoom in option here, but I went all the way into Winona and I kept going here. It's taking a while to render some results for us. We'll give that a minute. So you'll repeat this process till you can get zoomed into the area that you were studying, so your study area. So I'll pause this and wait for this to catch up. Okay, so as we're continuing to zoom in, you'll notice that what I wanted to show you is once we get into that scale factor rendered scale, if I just double click here on St. Mary's and Winona, you'll see that the next threshold starts to pull up some contours for us. And so all I did was kept zooming in here to my area, and you'll see these contours get progressively more accurate as we render our scales a little bit more. And so I was off in this area back in here, and eventually you'll get into a threshold where you cannot go in anymore. And so this data right here will be some of the elevations that I can use to compare to my results for my elevation contour layer. So the next step that you'll want to do is download some data. And so go ahead and click this button up here. And this then brings up the same information that I provided to you in these graphics right here. So I'll be downloading this data right here. And now what you can do is either freehand a polygon or just select a polygon. So if I click on polygon right here, and there's a base map option too, which I may advise you to turn on, then you can really see your features here. So let's go ahead and select our base map. It's taking a second to come in here, I think. Maybe I need to zoom out. See if we can get a base map. I'm going to pause this for a second and see what the holdup is here. Okay, some of our options just weren't showing up there, but if you were to select the base maps icon up here, go ahead and push that, and then you'll see some different options that come in for base maps. And go ahead and select the imagery right here, and then we'll see the imagery drop in underneath that. And so at that point, we'll want to download some data, and we'll say polygon. And then for me right here, I'm just saying, okay, I just want this general area. So left click throughout here, and the size of our data that the MinTopo provides for us is going to be tiled in a much larger area. So you'll be receiving a lot more data than what you actually need for your small little survey area, but that's okay. So in step 2, as I have highlighted here in the lab guide as well, you may want to select some of the finer data that's provided here. So there's a 1 meter DEM, and if you wanted to use some of the LAS files for the raw LiDAR, you could do that. I don't know if you need to, but at least at a bare minimum, select the contours and select the 1 meter DEM, or the smallest data that you can find for that. So what you'll do then is enter your email and some of the steps for data processing next. So once we're in here, if we select our 1 meter DEM and probably our contours, those will be really the two big ones that we'll need, just our DEM and then our contours, because that's what we created from our elevation. We created a DEM off our elevation points and then contours from our elevation points. So we'll see if we can retrieve a DEM and then contours from our area, which in gray here is the tile that we will be receiving. So once that's completed, we'll select our product types, And for us, we could select an ESRI geodatabase, so all of our information that we'll receive will be sent to us in that manner. And then simply next, enter your email. So go ahead and type your email in and then select submit. And once you do that, you'll receive a notice right here that says you are number 5 in the queue, or you are number 2 in the queue. And usually this will be pretty quick, maybe 5-10 minutes tops probably, and then you'll receive your data to start looking at. So we'll then next explore how we're going to view that data in an ArcMap session. So let's go ahead and take a look at that next, right here in step 33. So I'll show you what that looks like. When the data comes to you, you'll receive an email that looks like this, and you'll say, here's my LiDAR data. So what you'll do is you can select this and download that information. So we'll let that come in here and you'll see what that looks like. So this is downloading for us, and I already downloaded this twice here. That's why we see this here. Let's go ahead and take a look. I'll pause this and then show you what that looks like in our downloaded folder. Okay, with that data downloaded, this was, I have 2 downloads in here, but this was my original one here. So let's go ahead and left click, double click on this and open it up. And originally I downloaded some LAS files, but we don't really need that. But instead what I'm interested in is this LiDAR folder. So what I want to do is I'm going to copy this LiDAR folder. So I'm copying that out, and I moved that, and I brought that over into my working directory, and I just pasted that in here. So that's this LiDAR geodatabase. So I just simply copied that from my zip file, and then downloaded, or just copied it from here, pasted it into my CTemp. And from there, what we can do, if I turn off some of my other information here, let's go ahead and explore to see what our data looks like from our LiDAR database. So in this LiDAR database, this will contain our DEM that we selected right here. Remember, we looked at that, and then our contours. So let me look first at the DEM. So you can select that, load that in, and this looks a little bit cruddy here. Not quite what I was expecting. So we'll want to see if we can change that. Well, that's probably not quite how I was envisioning that, although this may be in meters. Let me just check this for a second to see if we drag this in a new data frame. No, it's still, I'm gonna have to look at this a little bit further. I'm looking right here at all the data values, and they're all changing. So there are definitely cells in here, but the display is not. I'll have to look at that, folks, and see what happens with that. But I guess in that sense, we activate our data frame back to where we were. I'm just going to remove this for now and load in here. Let's double check the contours. Okay, so our contours populate in here just fine. Something's going on maybe with that DEM. So try your DEM, and if there is a problem with that, I guess ideally we do not need that. If you're a little bit more advanced, what you can do is calculate, or if you're interested, I could show you how to do that beyond this lab here. But we could should be able to take our elevation lines right here and convert those into a localized DEM for our area here, and so we could use the elevations in those contours to create a DEM surface. Not required, but I could show you how to do that if you want to, if you're interested. So we have our contours and our min topo contours going on right here. So turn off our base map. Here we see our data points that we collected, followed by our elevations from min topo. So we could see our XY locations are pretty darn good on here. I was at the edge of a field line or a wood line right here, and then I was on a road surface right along here. So the elevation or the contour lines from from LiDAR are pretty good. And they seem to follow the general trend of my data points nicely in that the data is tapering off in this direction, kind of following my mouse all the way down. So those LiDAR-based contours are pretty darn good. Now let's take a look at the contours we created off our Z values. So the contours we created were off our elevation points. So I'm going to maybe change this to another color so we can see them. We'll try maybe red, see how that looks. And so if we load those in here, we kind of have a blue and red going on here. Now, this is just what I'm expecting because a lot of our Z values are going to be inaccurate. And so I want you to think about, in your case, what are some of those reasons for that inaccuracy? But it's not to say that in all cases, some of the areas could be pretty similar. So maybe in some areas of your little survey in your region there may be a lot of good similarities. So if we take a look at our elevations, there were some general high spots in here which seemed to collect fairly well, and definitely up here there were high points that dropped off, kind of going down this way. Along the road, if we turn on our base imagery, we can see our road that follows along here. And I tried to capture a small ditch in here, and it kind of did. The contours captured that a little bit, that there is a small, you sort of see the water will flow again opposite of the V's. So we didn't do too bad of a job in here. The water will be flowing this way along the road and captured the high points along here. Now, the reason we're seeing just a lot of really crazy lines up in here and over here, even up on the cornering edges and on the right side over here, was because I did not take any elevation points in those areas. So therefore, when the algorithms are run to generate the surfaces or the contours, the interpolations are being made based on the data surrounding it, or so the known data surrounding. So these points right here are used to best approximate what's going on in these regions out here. So really the best that we can do is to isolate any areas inside of our known elevation points right here. So inside of that will be the regions you would want to compare and contrast and explore. So in a nutshell, that's the idea for our lab this week, is to compare and contrast those two surfaces and our elevation contours. So you may find that there are some areas that are really pretty good. You may find that there are some areas that are not really so good at all, but that's the point of this lab. I'm not expecting them to be ideal because they're not going to be. The accuracy of our units here that we're taking out are not survey grade, so they're not going to be that good. So I hope this gave you some insight, at least at a bare minimum, to get going on your lab and have fun with this. And it's all about creativity and exploring your data. So there are no right answers. There are just explorations of where things went well, where things didn't go so well in your data collection processes along the way. So if you have any questions, please let me know. Otherwise, I believe that was about it in terms of our tutorial here, to take a look at the sample data and refer back to your agenda for those items to explore and discuss. And in general, what I'm referring to with that simply is this part here this is also in our agenda, but what are some cool things that you are denoting in your process when you're exploring your data, when you're looking at that? Some other highlight things too that you may want to do. I'm not sure what was going on with those 1 meter DEMs here, but like I said, for folks, if you're a little bit more advanced, you could create your surface. When I say surface, I mean this right here. you could create your surface or take this surface, and if we can get our other, the EM surface from Mintopo going, you could take the difference in elevation values between the two of those simply by subtracting the differences perhaps, or there's some other ways we could probably do that. And you could create a whole new surface that will show you the total variability between those surfaces that you can explain. That's one scenario. You could also bring this into, like I said, 3D Analyst or some 3D viewers or 3D scene and look at how these surfaces render themselves in a three-dimensional state. So that might be really neat to do as well. And you could also generate some slope data from the elevation maps here too if you wanted to do some gradient analysis or gradient profile analyses. So these types of things I'm speaking to just now are above and beyond what we need to do for a bare minimum. But if you've done some of this before and you're a little bit more experienced, here's a way that you can showcase your talents and do something a little bit more advanced to help you learn in that process. So if you have any questions about any of this, please give me a call. Otherwise, we'll look forward to seeing you again virtually next week, and we'll go from there. So have a good evening, folks. Thank you.